Okay, in this tutorial we're going to have a little look at how to set up a simple drawing. We've chosen a relatively simple part for this one so as not to get too sidetracked on creating a very complicated drawing. But what this shows you in this instance is how to set up an assembly type drawing, how to do some of the tasks that are associated with assembly drawings specifically, like bills of materials, balloons that tie with the bills of material. We'll look a little bit into things which aren't assembly drawing specific, such as editing sheet formats within Solidworks. So you can see that this sheet format is a custom format. Now this started life as one of the standard sheet formats in Solidworks, and we'll look at how you edit those. We'll also look at some things which are sort of general to all drawings, the types of views that you can insert. So you have standard projected views, you can put section views in there, detail views. So some of these things are specific to assembly drawings, some are more generic, just general drawing skills, and then we'll have a little look at editing the appearance of some of the annotations within the drawing. So when I say annotations, I kind of mean everything that is sort of text based. So all these dimensions are classed as annotations. Text can obviously include digits, so these have all got digits attached to them. The balloons are annotations, even down to things like the numbers or the letters assigned to the detail views or section views, or the arrowhead styles. All of these are classed as annotations, and you can make drawing-wide changes to these that save you having to go in and change each one individually. And then when you've made all those changes, you can save them so that you can quickly just call them up the next time you create a drawing. There'll be other skills as well that we cover, but as I say, some of these are specific to assembly drawings, some are just generic drawing skills, and how to modify the standard drawings to suit your needs a little bit more. So yeah, let's get started. So the first thing that we're going to do is we're going to create a fresh drawing. We're going to use this drawing as our guide, so we'll keep this open in the background. So this might be quite useful. One of the first things I'm doing, I'm clicking on an assembly view in a drawing, and this icon that pops up there allows me to open the assembly that view is showing. So that works for parts as well, but we want to create a new drawing of this assembly. So then what I'm going to do is I'm going to go to the File menu, go New File. I'm just going to create a standard drawing using one of the inbuilt SolidWorks sheet formats. So OK. Then I get a list of the sheet formats and sheet sizes that are available to me. If you have this box ticked, your sheet formats will be filtered down to only include the ones that are part of the standard that your system's been set to. So my system's been set to BSI standard, but I want to view all the sheet formats, so I deselect that box. So it might have been useful just to note what size of sheet we were working on before. Now I already know that it was an A4 landscape sheet, so I'm going to look for a format which is as near to that as I can get. And this A4 ANSI standard is probably the nearest one that we've got. When I click on it, I get a little preview of kind of what size the title block is going to be relative to the sheet size. You can kind of see that this preview is squashed in the horizontal. It appears more square than an actual A4 sheet would be. But yeah, if you're happy with that, you can click on OK. Then we get a blank sheet where with that A4 format that we selected, populating some of the sheet, and then a big blank space where we're actually going to place our views. So the first thing that we're going to do, we're going to drop some views into this sheet. So let's have a little quick look back at our reference. Now I would say if I was putting these projected views in, so you could put this top one in and then project this view from it and then project this bottom view from that, but I would tend to choose this view here as the initial view, and then this top view here is a projection of it, and this view down at the bottom is a projection of it, and obviously this one here is a section view. So yeah, let's put this one in first. So what we're looking for is a view of our assembly that looks something like this. So that will be our initial view. So back to our blank sheet. So in order to put views in here, there's a couple of ways of doing it. We can go up to the view layout toolbar and select model view there, or the preferred way in sort of modern copies of SolidWorks is the view palette. So if you click on view palette there, initially there might be nothing shown in there. Now what you might have to do is from this drop down list at the top, select the assembly or part file that you already have open that you want to create this view of. Now we already have this chain case assembly open in the background. If we didn't have any assemblies or parts open, we could browse the hard disk by clicking on that button there, and then we could browse the hard disk and bring an assembly or bring a part file into memory and start placing views of that. But obviously we have something open in the background that we want to create a view of, so we can just click on that. If you give it a second to load up, you will get all the standard views previewed in the view palette, and this tends to be why the view palette is preferred over just clicking on model view up here. It's because you have a little preview of what each of these views is going to look like, so you can kind of select the one that you want visually rather than just bringing in the default view and then having to play around with the viewing sort of angle that you're looking at it from. So if you remember back to what we're trying to recreate, I think this one is the nearest match. So I'm clicking and dragging this with the left mouse button, letting go on the sheet. Now your system might be set up such that when you move your mouse pointer away from that initial view, you see a projected version of the view. That's fine. My system's not quite set up like that. I have to select the view and then go to this projected view option. But either way, you should be seeing a box like that, or maybe even you're seeing the box that has a preview of what that view is going to look like. But essentially what we want to do is click there to get a projected view in that direction, and then again your system might be automatically offering you a view down here, in which case you can just click and accept that. I have to do a little bit of extra work on this system, so I'm going to click the parent view and then say I want a projected view, and then it gives me a preview of how big that view is going to look, and then when I click it drops that view on the sheet. So those are my that's my initial view. You can see that listed over here, drawing view 1. That was the initial or the first view that I put in, and then these two views, they have a slightly different icon. That's the projection icon. So that is the parent view, and these two are child views of that parent. So that has a few knock-on effects. If I want to move this child view left to right as we're looking at it, I'm not allowed to. I would have to do that by moving the parent view, and you can see both projected views move with it. Now the projected views, I can move them vertically because I can move them in the projection direction, so I can make them further away or closer to the parent view, but they are locked to the parent in terms of their horizontal position. So something that has become apparent if we look back at the original is that the scale of our sheet is wrong. So if we look back at this original sheet, we can see the scale was set as 1:2 for the entire sheet. Now obviously there are views on here like this detailed view that don't follow that default sheet format, but they have annotations attached to them that specify what scale they are shown at. So everything that doesn't have an annotation attached saying what scale it is, the assumption is that it follows the default sheet format. So I'm going to change our sheet scale on our new sheet. So if we go back to our sheet, you can see it's set at 1:5 at the moment. Probably the easiest way of changing the sheet scale is to right click on the sheet up here. So you can see in the same way that you get a feature manager here when you're creating a part, or you have an assembly manager when you're creating an assembly, you have a drawing manager when you're creating a drawing. And you can see that we have the sheet that we're looking at, at the top level, and then within the sheet that we're looking at, there's the sheet format, which includes this border and the title block, and then below that we have our views that we've placed in. So if we want to change something about the sheet, we go select the sheet and then right click and then go down to properties, and then we're in this screen, which is similar to the screen when we were setting our sheet format back at the start. You can see all those ANSI sheet formats are listed there, but one of the options in here is to change the default scale of the sheet. So I'm putting 1 to 2 in. One other thing to note while we're in here is that depending on where you are in the world and what drawing standard you're working to, you may want to set the type of projection so it's suitable for your local standard. Now ours is set correctly for where we are in the world, so third angle projection is fine, but it's worth just noting that, because if you're working on a default version of SolidWorks, it may be set to a setting which is unsuitable for your particular local standard. So yeah, we'll apply changes, and the views change scales, which is what we expected them to do. So let's put this section view over here. So if we go back to the reference that we're working from, we've got a vertical section line there. So the section line itself chops through the part. It has arrows on it indicating the view direction, that you're viewing the sliced portion here, or the sectioned portion. So yeah, let's insert that into our sheet now. So generally when you're working on drawings, the two tabs that you spend a lot of your time in are going to be the View Layout tab or the Annotations tab. And if you spend a little while just familiarizing yourselves with those, there's various different options. You'll get a sense of what things are classed as annotations, but generally if you're inserting views or editing views in some way, you're going to be in the View Layout tab. So we want to insert a section view, so if you just quickly search across there, there is a section view button, so we're going to click on that. And what that offers up is a preview of a type of section line that the system is offering to me, and you can see I can apply it to any of the views in the visible window. And for this one, I think yes, vertical section is going to be fine for us, but let's say we wanted a horizontal section line, we can switch it over here and we can get a horizontal section line. We can get angled section lines, we can get aligned section lines as well, so just be aware that all those options are in there. So let's lock our section line into the position that we want, somewhere there. We don't want to modify the section line, we don't want to put sort of offsets in there or notch offsets or anything like that, so we're just going to OK that next menu. The next menu that comes up is, it's basically saying, do you want to section all parts in this assembly, or would you only like to section some of them? Now in this case we want to section everything in the assembly, so we don't want to put anything in this excluded components window. So again, we're just going to click through this, we're just going to say OK. Now what it's offering me is the opportunity to place the section view, so you can see it's a projection essentially away from the parent view, so we want ours somewhere here. So I've now dropped that view. So there's a few things that I could do with changing about that section view. So number one is, even though the section line itself, so this dashed line here, passes through the entire part, the length of it isn't quite long enough to avoid the arrowheads that have got the text attached to them, obscuring our view of that part. So what we could do with is making this section line a little bit longer. Now you can just click and drag the length of this line. So if you just click and drag slightly there, just to lengthen the line, yeah, that's a little bit better. And then this hatching around the section view is indicating that that section view is now out of date. So we need to do a rebuild. So the rebuild button is the same as the rebuild button when you're creating parts or assemblies. It's just that red and green traffic light sort of thing at the top there. So rebuild, or you can do a Control and B, I believe it is, if you hover over there, Control and B, or Control and Q does a full rebuild. So yeah, we put our section view in. So again, let's refer back to the drawing that we're trying to replicate. So there's a few more things that we can address that spring to mind. Before we get onto dimensioning these things, I think we'll put these center marks in. So center marks tend to mark the center of an arc or a circular feature on the part. You get them in the center of holes quite a lot. Obviously a hole is a circle. And then we've got one here because we've got a circular edge on this part and we've got a big circular edge there as well. So let's put the center marks in. We may even put a center line in on this section view as well. So we're doing some additional work that isn't shown to us on this drawing. So yeah, let's go back to our sheet. And again, if we had to choose one of these tabs to find our center mark tool in, hopefully you would surmise that it's not going to be in the view layout tab. We're not inserting a new view, so therefore by process of elimination it must be in the Annotations tab. And again, these icons are pretty self-explanatory. If you can't get their meaning from the text, then often the icon itself is quite useful. So we want to put center marks in, but if you didn't know the name of them, you can actually see from the icon what this tool actually does. So yeah, click on center mark. Now there's a few options here, so we'll try some of them out. So let's say I want to put a center mark in the center of this arced edge there. So there's an edge there which is part of a circle, it's an arc. It has a center point, and when I click on it I get a center mark inserted that is an appropriate size to actually break the edge of that arc, so you can see it's beyond the edge. And it's locked to the center of that arc essentially. Now I'm going to hit delete, or rather I'm going to quit out of there so it disappears, because there's other ways of inserting center marks as well. So if we go back into the tool, let's have a look at some of these options. For all holes, yeah, let's try that, and then let's just select this view by clicking on the box that surrounds the view. So you can see that box highlighting in orange there. And you can see it's searched through this view, it's found any holes that are contained within the view, and it's put center marks in the center of them. So that's one way of putting them in as well. And there's various options in there. If you have a pattern of holes that have an angular relationship, let's say, between them, then you can select options like radial lines that link into the center of the common axis that those circular patterned holes have come from. So yeah, different ways of putting center marks in. So let's put some more in on this. Let's put that one in and that one in, and we'll have them for the holes as well. I don't think they're in the hole centers on the view that we're working from, or the sheet that we're working from, but it's good practice to put them in there anyway. And then let's select this arced edge, so that indicates that this was once a circular component before it had these flats machined on it. And then again, let's do an all holes one and just select this view as well. So it auto finds the holes there. So that's how you put center marks in a drawing. The other one that I said that we might tackle is the center line. So when you're viewing a cylindrical face from the other angle, so you're not looking down on it as if it's a circle, you're looking at it from the side, so it appears as an oblong or a rectangle. Often you put a center line in to indicate that it is cylindrical. The face is part of a cylinder. So yeah, you'd use center line, and I know that that is a cylindrical face in that section view. So that face under my pointer there that hasn't been cut, or that has been cut here and here but hasn't been cut there, I know that that's a portion of a cylinder. So if I click on that, it's happy to put a center line in there. So that one's easy enough to put in as well. So let's go back and see what else we're going to tackle next. So let's put some of these dimensions in. So when we look at part drawings, which we will do in a following tutorial, we'll look at the various methods that you can use to put dimensions onto a drawing. Now the method that we're going to use here is just the Smart Dimensioning tool, which is very similar to putting smart dimensions in a sketch when you're creating a part file. Now, as I say, that's not the only option. There is another option to import the dimensions from the part or the assembly itself. Now, we're not going to cover that method in this tutorial, as I say, but we will cover both methods in the part drawing the part drawing tutorial. So yeah, just be aware that there are two methods, but we're going to use the Smart Dimension method in this one. So let's put this 25, so that lower section of this assembly, that's 25 high, and then the lid, if you want to call it that, is 3mm thick. So let's put those two in on our sheet. So Smart Dimension tool in the Annotations tab, that's what we're using. And again, this behaves very much like the Smart Dimension tool in sketching. So I'm going to select that face there, and I'm going to select maybe that point there. That's one way of doing it. And then what it's offering me a sort of snap. So it's saying you can snap that dimension to the left hand side here, so that's what that orange half circle is indicating, or you can snap it across to the right hand side. Now I can't quite see that, so I'm just going to zoom out a bit. There you go. So the snaps are quite useful. You don't have to use the snaps, you can just place this yourself if you want to do that instead, but it's being aware of what the system's offering you there that's the key thing. Sometimes it's useful, sometimes not so much. It's better to place the dimension yourself. So those are those two dimensions. Let's have a look at some of the others. I think we've got a dimension between these center marks, so that was the reason for putting the center marks in, to make the dimensioning of the distance between this arc center and this arc center easier to dimension up. So we've still got the Smart Dimension tool selected, so if we select that vertical leg of that center mark and that vertical leg of that center mark, and we can drop a 70 in there. Now currently it's hanging over into the sheet border, so I'm going to have to address that at some point, but that's okay for the time being. Yes, on this one it's at the bottom, so maybe we'll rejig that one a little bit. And then we've got a 20 at the side there, so let's put that one in as well. Smart Dimension 20 from there to there, and then let's replicate that 70 again and drop it in somewhere down there, and then hit escape because I don't want to put any more in just at this second. So I'm going to delete this one just by hitting delete on the keyboard, and then I'm going to try and space these views out a bit. Now this allows us to talk a little bit about editing sheet formats. So you can see that this view down here is getting dangerously close to overlapping this title block which came in when we selected the sheet format that we did at the start. And what we're going to cover in a second is how to edit these title blocks and how to edit the sheet format as a whole as well. So once we've done that, I'm assuming that we're going to get rid of all this section of table here. So what that means is I can be fairly comfortable moving this view so that it overlaps that table temporarily in the knowledge that I'm going to go in and edit this table and get rid of some of the content. So I'm going to pull that down there. I'm going to just drag these down a little bit. Yeah, I'm reasonably happy with that spacing. We may come back and just play with that a little bit later on. So what other dimensions have we got on this thing? I think that's around it. We're going to put this annotation in a little bit later, so we haven't used the dimensioning tool for that. That's just a straight typed annotation, which there are advantages to that in terms of flexibility, but you lose your sort of parametric link back to the model, so it can be a dangerous thing to do, because if you change your model in any way, this doesn't dynamically update, so you have to remember to go in and retype that. So yeah, pluses and minuses to that method of doing it. So let's put a exploded view in over here. So one thing that we haven't talked about at this point is the fact that the assembly that we're working from already has an exploded view in there. So let's take a pause for a second and just have a look at how you create an exploded view. So the tab that we're in this assembly environment isn't the feature manager or the assembly manager tree, which is where you would normally be when you modifying an assembly or creating an assembly. We were in the configurations manager. So configuration manager there. Normally that is sort of minimized like that, so there's just the assembly at the top. If you drill down a little bit into that, what you'll have in all your parts and all your assemblies is a single configuration, and that configuration initially will just be called default. So we're not going to get into the use of configurations here. We're just going to look at how you put an exploded view in the default configuration. So the way that you would do that is you'd right click on the default configuration, you go new exploded view, then we're in an environment where the system is looking for me to select some components to explode, essentially. Now in this assembly we only have 3 components, that's why we've used this simple assembly just to simplify this whole process. So essentially what we want to do is we want to take this lid and we want to explode it upwards by a set distance, and then in a second explode we want to take this cap on the bottom and explode it in a downwards direction, and then this thing here, the main case, just stays where it is in 3D model space. So yeah, I'm going to select the lid first. When I select the lid, I get these 3 drag axes, so I can choose to use one of those to click and hold and just drag it. I get this ruler system that I can measure my explode amount by. You tend to do this more by the visual that you're seeing in the window there rather than the actual value. So you can see 1 explode step has been put in there, so that represents what I've just done. So now it's looking for new inputs. It's accepted explode step 1. It's looking for components in here that I want to include in explode step 2. So I'm going to click on this component here. And then again, I've already said what I want to do with this. I want to kind of drag it in a downwards direction to about there. So the general rule of thumb is whatever angle you're going to view your part from in your drawing. So let's say we're going to view it from this sort of angle there. You want to be able to see a little bit of daylight or a little bit of space between each component. That's to avoid confusion. If one component is overlaying the other one visually, it can lead to confusion as to what each component includes. So what geometry belongs to one component versus belongs to the other one that it's shown on top of. So you can see now I've got my 2 explode steps, and then within them again you can drill down 1 level and you can see the members of each step, and then if you need to edit these steps in this environment, it's as simple as just selecting a step, an arrow appears which represents the direction that you drag the component, and you can just click and drag again. So quite easy to modify. So we'll OK that. So now what we've got, if we have a look inside the default configuration, we have a new exploded view called exploded view 2. So the one that I used in the original drawings was called exploded view 1. So we're going to use exploded view 2. So you have to do that prep work first in your assembly before you can put an exploded view in your drawing. So if we go back to our sheet, and then we want to put an exploded view here. So we'll go back to our view palette. It's given us a warning here, the view palette is out of date. Click refresh to update it, so we will. There's the refresh key. It'll load the new views up in the background, and then it offers us up some options here. So I think the nearest one to the one that I need is this one at the bottom here, isometric exploded. Now the fact that it's an exploded view is good for us, but the fact that it's locked to the isometric angle of viewing is not so good, but we can change that once we brought it in. So if we click and drag, drop it roughly where we need it. So as I say, it's picked an exploded view. It's actually gone to the top of the list and picked exploded view 1. If we want to specifically use that one that we've just created, we can edit that there. So you can see Exploded View 2. It's a little bit close on Exploded View 2, but we will use it because that's what we said we were going to do. So the next thing I'm going to address is the angle of viewing of this view is not really suitable for us because it's doing what I said you shouldn't do, where visually these components are overlapping each other. So that's not good practice for the reasons that we've already talked about. So what I want to do is I want to rotate my viewing angle. And the way that you do that is you select the view and then click on that icon there. So it's like a sheet with an arrow coming out of the sheet. Now what that allows me to do is it highlights the view that I had selected, and if I click and drag, you can see it's almost as if I'm in the SolidWorks environment and I'm modeling this part. So let's have it at sort of that angle, like that. And again, there's a little bit of artistic license here. There is no hard and fast rule really. So yeah, what I'm taken away from that is I could do with exploding the lid a little bit further upwards and the cap a little bit further downwards as well. So I'll OK that edit, and then I'll quickly jump back into the assembly, activate Exploded View 2 by double clicking on it, and then I'm going to edit these steps slightly. So I want to drag this thing a bit further out and then pick step 2 and drag this thing a little bit further out as well. And then when we get back into the sheet, yeah, it should have updated it. If it hasn't updated there, you may have to do a rebuild, but ours is auto updated. So let's go back to what we were working from. So the orientation is slightly different. You get the idea that we could drag the orientation so that it perfectly matched this. For our purposes, I think the new orientation is just as legible, so I think we'll stick with that. So the next thing I'm going to do, on the sheet that we're working towards, this view has a shaded appearance. So again, very much like when you're working in the part environment, you can change the appearance of your model from hidden lines removed, which is what we're looking at now, to shaded with edges, for example, or just a shaded option, which is slightly less legible in my opinion. And then you can have things like hidden lines visible but they're dashed, or full wireframe where there's no distinction between the lines that should be hidden by geometry and the lines that should be visible. But we're going to pick shaded with edges. So we've got the visuals of this view sorted now. The next thing that we're going to do is we're going to put the table in down here which lists the members of this assembly. So you can see that it's got 3 components in this assembly. So that table is known as a bill of materials, or BOM for short, BOM, and it's a table. So I keep saying it's a table. So it may not be obvious, but it's classed as an annotation. And if you search the Annotations tab, you should be able to see that there's an option at the end for tables there. I've already told you that it's referred to as a bill of materials. So bill of materials, it then asks for a little bit of input from you. It says select a view that you want this bill of materials to be referencing. So it's this view here, and that's because we're going to put some balloons pointing at these components that are going to tie in with the numbering of the bill of materials. So at this point we're not going to edit anything on the options here. We're just going to insert it, and then we may play with it later on to get it looking more like the sort of bill of materials we want. So we'll click on OK. Then I get the bill of materials attached to the underside of my pointer, so wherever I move my pointer the bill of materials follows. Now the bill of materials that you're looking at, if you've got a default install of SolidWorks, may not quite match this. So this has had a little bit of work done to it to make it appear like this. So the first thing that I'm going to do, I can see that the description column, none of these parts have had a description saved within them. So the drawings portion of SolidWorks has no description data for any of these parts. So that's what you would do. Normally you would store that data inside the part itself, but in this case it's not being populated at all. So if I'm happy with that and I know that I'm not going to ever put a description in any one of these parts, I'm just going to go with a name or a part number, then I can delete that entire column just by clicking on the top of the column, hitting the delete key, column disappears. And again, your bill of materials might not look exactly like this, but we're going to go through methods of editing this bill of materials now. So what sort of things can you do? You can change the overall size of the text. So this icon at the top, this four-way drag icon, essentially selects every cell in the table. So now if I want to change the font that I'm using, let's say, I can do that up here. I can change the size of font. I can go by point size or the actual height of each letter. So 3mm high down to 2.5. You can affect the height of the cells if you've got the entire table selected, so we'll try that. See if we can get them all to scale. There you go. So if you select the entire table and scale the height of one of them, they should all follow suit. Or you can do that individually. You can affect the width. So this behaves very much like tables in something like Microsoft Word or even Excel, working with columns and rows. So that's pretty self-explanatory. One behavior which it's worth being aware of is you can see that this thing tries to snap itself to other geometry, such as the margin lines there. So when I get near the margin lines, it tries to snap itself onto them. Even tries to snap itself onto the actual title block of this sheet. Now that may be preferential for you, or you may just want to leave it floating in free space. Yeah, that's entirely up to you. Right, so we put a bill of materials in, and this is the order that you've got to do these in. Next, we're going to put the balloons attached to this assembly view that we told the system that this bill of materials is referring to. So that's how you do this. You put the view in first, tends to be an exploded view, doesn't have to be. Then you put the bill of materials in that refers to that view. Then you put the balloons in that refer to the bill of materials. So if we pre-select this view, so click on the view box there, so the surrounding box, and then I think I'm going to use auto balloon. So this will have a decent go at trying to attach balloons to all the components in your assembly. Now sometimes it's successful when you have a simple assembly that's well spaced out, like the one that we have here. It's fully successful. You can see these balloons that have just appeared. Sometimes if their components are obscured by other components, it's less successful. And when you've completed the auto balloon and you've clicked on the green tick, you then have to go into the balloon option and manually attach some balloons to some components. But the two options essentially arrive at the same outcome, which is you have balloons attached to your components that correspond to the bill of materials table that you've just inserted. So I've just shown you the two techniques there. The auto balloons on the left, it did a good job in that it got all the components with balloons attached and annotations attached, but the positioning of them was less than ideal. So I chose to, rather than drag them into the correct position, just use the standard balloon option and manually attach some balloons. But you've seen an example there of the two methods of doing that. So if I delete these auto balloons and keep the ones that I put in. So let's go back to our reference sheet again. What else can we do? Right, we've got a detailed view here, which is being driven by that detailed circle at the top there. So let's insert that on our sheet as well. So view layout, because we're inserting a new type of view, we're not inserting an annotation. Detail view is an option in there, which again the sort of icon's quite self-explanatory. Detail view, and what we're going to do here, once I've zoomed in slightly, is we're going to draw a circle. So it's just the sketch circle tool that we've got access to now. So the first click is going to define where the center point of the circle is. So click. Second point is going to be the radius of the circle, so how big it is. So let's click about there. It assigns a letter to the detail view automatically, and then I know that I'm going to free up this space down at the bottom here, So maybe I could drop the view in there if I really wanted. It's a bit difficult to work on now. Or maybe it would be wiser to temporarily just drop it in some free space outside the sheet, knowing that I'm going to free up some space here, and then I can bring it back in again. So yeah, there's the detail view. What do we want to edit about that? I think the scale is a little bit out. I think the scale should be 2:1. So the way that you would edit that view is if you just select the box around the view there, you get all the options related to that particular view. This one here controls the specific scale. You can pick a scale from the sort of pre-made list there, or if you want to define your own scale, you can type your own scale in there as well. But we need 2:1, so it's one of the ones on the list. So one thing to note about these section views and detail views is they get the annotation text auto-generated based on things like the next available letter in the alphabet. So we use the letter A for the section view, or the system used that letter, therefore it knows the next available letter is going to be the B, and it assigns that bit of text to the view so that when I move the view around, the text follows it. Now what I can do is play around with the distance from the view to the text. So you can see that I'm dragging the text a bit closer, and then when I drag the view around, the text will come with it, but it will be closer to the view. And obviously you can drag it to the side of the view, you can drag it to the top, you can drag it wherever you need to. But that's the behavior of the system. And really you don't want to go in here and manually edit that text. You can, the system doesn't stop you from doing that, but that text is dynamically linked back to the setup of the view itself. So you could manually go in here and overtype something which should be left as a dynamic link so that the system is aware of what letter is being used. So don't make that mistake of overtyping that. Just leave it. You can format that text if you want to. You could change the font. That's not going to break anything. But generally you wouldn't do that per view. You would do what we're going to do a little bit later on, and you go into the actual setup of the drawing sheet itself, and you tell it that all detailed views share the same font size. So yeah, let's get on with the next bit of work that we need to do. So we need to edit the sheet format. That's what we're going to do next. We're going to take some of these table entries out here. We're going to add some more things into the title block that we're going to keep over here. We're just going to make some general changes to the sheet format. So the way that you edit the sheet format itself, so you can see that I can't currently have any effect on any of these things which are part of the format. You can see I'm trying to double click on these bits of text, it's not letting me do anything. If I try and highlight them and press delete, nothing happens. Essentially you can think of them on a different layer to the layer that we are currently editing. We're currently editing the actual sheet, and what we want to edit is the sheet format. So there's a couple of ways of getting into the sheet format. If you can find a piece of the sheet format that doesn't have a view overlaying it, so this bit here down here doesn't have anything overlaying it, you can right click to get the quick access menu and go to edit sheet format. That's one way of doing it. Or if you're over here in the drawing tree, you can right click on the sheet and go edit sheet format. Either way is fine. And what happens when you do? So you drop onto this sheet format layer. So temporarily your sheet layer disappears. So you can see everything that I'd done in terms of layout of the views has now disappeared. It's only disappeared temporarily until I tell the system I'm finished editing the sheet format, and then I can exit out of this layer and see all the layers again. So I can't break anything that's actually on the sheet itself. I'm only editing the format at this point. And it's a fairly low-tech method that you're going to use to edit this. Essentially what we're looking at here is a sketch made up of lots of horizontal and vertical lines. And you can test that theory by, if you grab a corner of this thing and just drag it, you can see it behaves very much like the Sketcher environment. hopefully you can also see that there are actually some relations already in here. So you can see that these lines have been told that their endpoint should always contact this line. This line and this line have been told that they share an endpoint. So there's certain relations that have been put in here automatically, but then there's other relations that you would think should be here that aren't. The fact that I can drag this line away from horizontal, maybe you want to lock it to horizontal, but then that has knock-on effects. So you can see you've got to be quite careful as to what you edit and how you edit it, but you've got to keep in mind that this is essentially quite an underdefined sketch. But having said all that, there's always the undo key. So whatever you do, as long as you don't make too many changes after the point that you want to undo back to, you should just be safe just clicking on the undo at the top there, or Control and Z, and it should take you back to a point where you can start again. So essentially what I'm looking to achieve here is I'm looking to keep everything to the right of that line. So all the text boxes and everything to the right of that line I want to keep, and everything to the left I want to get rid of. So probably the first thing that I'd do is I'd take the trim tool in the sketch tab, because I've already said this is just a sketch. So all the sketcher tools active, you can use all these sketching tools to actually make edits to this title block. Then I'd probably use the trim entities and power trim option, and I'd just click and hold and draw a freehand line down through all these lines to split them in two, so that when I edit this portion here or delete it, it's not going to affect anything in this portion here. So now that I've used the trim tool, I can OK that. I don't need to use the trim tool anymore. Then I'd probably do a box select. So I'd go from the top left down to the bottom right and just stop about there. That should select everything that I need. It's got everything that I need. It's not deleting these edges on the actual border, which is good. I haven't got that bit there, but I'll come back in and delete that in a second. And then I can just hit the delete key. And then that extra little bit there, I can select it directly and hit delete. So let's see if we can refer back to what we're aiming for. So this is kind of what we're aiming for. So some text saying do not scale drawing and revision at the top. So again, the actual content of this text isn't as critical as just learning the methods by which you would edit this if you needed to edit it. So yeah, let's go back into ours. Do not scale drawing and revision at the top. So we already have those at the top. So what's in the next box down on our reference sheet? Last saved and then a date. So we can just type that in. So we need to type some text. There isn't an option for that in the sketch toolbar that I can spot, but some of the annotation options are still active, so we can make notes. So if I just want to type last saved. Now on our reference sheet, all of this was in caps. You don't have to use the caps lock key. There's a less destructive way of doing that. There's an all uppercase option here. The nice thing about that is you can switch it on and off. So all uppercase, last saved, and then I think it was a colon. And then what I'd like to insert here is a value which the system auto populates based on when the user last saved this this drawing. So you can do that. You don't have to manually type all these values in, because if you did manually type them every time you created a new drawing, you'd have to go into the sheet format and manually type in the date that it happened to be. So what we can do is get the system to fill that bit in. So while you're editing some text in a text box, you want to insert some piece of data, some piece of metadata that's part of the file itself. You go over to that icon there, link to property. So in a lot of programs this is called metadata, in graphics programs like Photoshop, metadata. Solidworks refers to it as a file property. And where is this file property going to come from? It's going to come from the current drawing document. So current document. What is the property name? Well, let's have a look down some of these. So there's the file name. No, that's not it. The short date, the long date, the author. No, 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 no. Last saved date. Yes, that is the one. So we get a long version form of the date. We can play with that. We can say let's have it short. Let's not have the time included. So there we go. There's our date. Click on OK, and now it will auto-populate that. So every time someone loads this thing up and makes a change and presses save, that date will auto-update. So that's quite a useful thing. So we can OK that note now, and we can drag it to roughly where we need it. Maybe we decide that the text was a bit big, so we double click on it and say, can we have it 2.5 millimeters tall instead? Yep, that's a lot better. Then I think we have a vertical table line there, so let's put that in. So again, that's just a sketched line that we want to lock onto that line there, lock to vertical, and lock onto that line there. And then we can get out of the line tool. We don't need the line tool anymore. What's to the right of that? Drawn by, and then the initials of the person that drew this thing. So let's see if we can do that as well. So annotation, note, drawn by, and then again I do all uppercase. Now depending on your login on your system, maybe you could put this in as a static value, like I'm going to show you right now. So those are my initials. Maybe this is my sheet format. Maybe nobody else is ever going to use this, so I know that I'm always going to be the person that draws these. So in that case, putting a static value in there, just type in something is absolutely fine, and then you would drag that into position. So that would be absolutely fine. Maybe tweak the size of it a little bit like we did with the other one. So that's okay. But if you want to store the login name of the person that saved this, then you wouldn't want a static value. You'd want to go into the file properties again. So link to property, current document, and then which property, last saved by. So again, my login on this machine happens to be exactly the same, but yeah, you can do that either way. You can have a dynamically generated value that changes depending on who's editing it, or you can have a static value. It's up to you. So let's see if we can get through some of the others. Title is the file name of the actual assembly itself. So you can see if I hover over this name of the assembly itself, which is what this is, chain case, a little tooltip pops up that says $PRP. That means PRP refers to property. So it means that SolidWorks is going to look in the file properties and it's going to populate this box with a file property known as SolidWorks file name. So whatever the file name of the assembly is that you're creating a drawing of, or the part that you're creating a drawing of, that will get put in that box there. Now that's all okay, but I'm not going to call that the drawing number. I'm going to use that as the title. So again, I'm not making a major change there. I'm just changing the box that I want that actually located in. So there's a few other things that we're going to put in. I think the scale and the number of sheets and maybe the sheet size are all set. Yep, we already have those. Drawing number's not required. I'm not running a drawing shop that has a title and a drawing number. These things just have a file name, which is the title. There's the third angle projection symbol that we've got at the bottom there. Now, the way that we're going to produce that, you can try and import some DXF file or a DWG file, which is a possibility in SolidWorks. It's probably easier just to manually draw this thing. Seeing as what you tend to do is you edit the sheet format once, and then you can take a copy of that sheet format and save it, and then every subsequent drawing that you create you can just pull that format into the drawing. So you only have to do this job once really. So yeah, we're going to manually sketch out this third angle projection symbol. So let's do that now. So it's got to fit in this section here. So we're going to use the sketcher tools. We're going to use the circle tool to begin with, so we'll sketch that smaller circle. So essentially what we're sketching is a cone, a truncated cone. So you can see I'm just building it up from circles at this side. Then I'm going to have to put some projection lines in that are going to help me when I draw the side view of this thing. So I'm going to put some horizontal projection lines in like that, and I'm going to put some vertical projection lines in like this, which will all make sense in a minute. And then I'm going to hit escape, and then I'm going to delete some of these, so the diagonals I don't need at all. And now you can see hopefully what's going on. So I'm going to join these two together with a line, and that will be the back of my cone, and then I'm going to join these two together with a line, and that will be the front of my cone, and then I'm going to join the two of them together like that, and that essentially forms the side view of my truncated cone. Then I can delete these lines, so if I get rid of these, and then what I need to do, I need to put a center mark in the center of here. Now I don't think the center mark's available when I'm changing the sheet format, so I've got to sketch my own center mark. So for this line, I want to use the midpoint line option. So midpoint line. What that allows me to do is the first click places the middle of the line, and then as I drag the length out like this, hit escape, you can see the line is equally spaced between one side of the midpoint and the other. So I'll do that again. Midpoint line, drag it that way as well, hit escape. Yeah, that looks reasonable. Then I'd just get the standard line tool and I'd put a center line through this cone there. That's more or less okay. Now if you need to move these or scale them slightly, they don't really have any dimensions or very few relations on them at the moment, so they can be hard to move around. Now you can see as I click and drag that, the center lines don't move with it. So let's say for example I needed to move this as an entire block of drawn content. I would use the move option in the sketch toolbar there. What that allows me to do is it allows me to do a box select around everything that I want to move. It will highlight it then, and if I do a from to move, I can click on a start point, so let's say that point there, and then you can see it all follows my mouse pointer as a block of drawn material. So that's how you would move it. And likewise, if I decide the scale of this thing is a little bit big for the space that I have between my two lines there, there's an option in the drop down list under move which is scale, and again it behaves very similar to move. If I do a box select, so I'll just undo that because I didn't mean to do that. So scale entities, let's see if we can do a box select on this without getting things that we don't require. So there we go. So we've selected the things that we require. What scale do we want to scale them to? So let's say 0.9 of their current size, so that's 90% of their current size. Hit enter. Nothing happens to begin with, and that's because I need to tell it where the base point of this scale is going to be. So select there. I'm going to choose that center point, and you can see as I click on it, it applies the scaling factor that I've requested. Now that fits within the boundaries of those lines a lot better in my opinion. So you OK that. So yeah, it can be a little bit tricky to work with this method, not fully defining sketches, but yeah, you only kind of have to make these modifications once. And as I say, we're just going to look at in a second how you would save this sheet format for further use. So yeah, let's say that we're happy at that point. So you have to tell the system you're happy with your edits that you've made. You now want to exit the edit sheet format mode and get back into editing your drawing itself. So it's that icon at the top right, similar to the exit sketch icon. So if we click there, it accepts the changes that we've made, and we're back in our sheet edit mode. So there's only a few things that we need to do now. Now the default behavior of SolidWorks is to color any dimensions that you add to a drawing using the Smart Dimensions tool in grey. And when we look at in the part drawing that we're going to look at later, when you insert model items, which is the method that you use to import the dimensions that were used to create the actual parts themselves, those dimensions are coloured in black. So it allows the user to make a differentiation between driven dimensions, which are what the smart dimensions are, and driving dimensions, which are what the imported model items are. Now in a lot of cases, in a lot of drawing departments, that distinction isn't required, and in actual fact it's quite damaging, because what ends up happening is you will distribute a drawing maybe to manufacturing staff, and they'll not understand why some of the dimensions are in grey and some of the dimensions are in black. So at the very least it will lead to an inquiry from them as to some sort of clarification as to what that means. And ultimately the answer to them is, as far as they're concerned, it doesn't mean anything. So it can be quite confusing. So the thing that we get into is, how do you change the colouring of any given drawing element? So how do you change all these dimensions that we want in black to black without manually doing each one separately? So one easy way of doing that is you place all these dimensions on a separate layer of the drawing, and then you assign that layer of the drawing a specific colour, and then anything that's on that layer will follow that colour. So we're going to edit the layers now. So normally the layer editing menu or toolbar isn't visible, but if you click at the top here in some free space, so you can see on this toolbar there's a lot of free space up here, right click there, and you can see some of the hidden toolbars that you don't normally get to work with. And one of them is the layer toolbar, so there it is, layer, and this little box pops up, and we've got a format layer, a non-layer, and then a per standard. We're going to create a new layer and we're going to call it dims for dimensions. So click on layer properties, you get a slightly larger menu, click on new, and then add a layer called dims. Now the default colour for all layers is black. In this case that's good for us because that's what we want, but if we wanted a different colour we can click on the layer colour there and we can change it. That's okay. So okay, and what we need to do now is we need to collect things by holding down Control and clicking on them that we want to place on that layer. So I think that's all of them, yeah, in this case, and then in the layer drop down apply them to the dims layer, and then when you click off them they've all turned to black. And further functionality that allows is, if at any point I need that layer to be hidden, I can do that. I can hide the layer temporarily. I can highlight the layer by changing the colour to a very bright colour, if that's useful as well. So layers are quite a useful tool, and for anyone that uses a traditional 2D CAD system like AutoCAD, layers are very much used in that sort of world as well. So yeah, what else can we do? We can also see that a lot of the lines in our title block or our sheet format are actually greyed out. So let's see if we can change those now. So I think what I'd do if I wanted to change those is I'd right click and go back into edit sheet format. And then in this case I'd probably create a new layer. Or maybe I'm surprised that they're not all on the format layer already, so maybe I'd do a huge box select and I'd place everything on the format layer. Yes, and that solves the problem, because there was already a layer in there called format by default. It's just that the sheet format wasn't placed on that layer. The sheet format had no layer, it was just unclassified. So all I did was select everything with a box select and then applied it all to the format layer. which again we can check that now. If we turn the format layer into a very bright colour, we can see what's on it. These text numbers aren't on it, but I don't think we really need to worry about them because they're black already. We don't need to edit them. So there we go. And then again, we're editing the sheet format. We don't want to be, so we exit out of that editing mode. So I think that's more or less everything for this tutorial. I think there was just a little bit of annotation there, which is an easy enough thing to do. Note serves as a method of just typing some text. So if you just want to make a little note, or if you click on note and you hover over a piece of drawing, it gives you a nice little arrow or leader line that attaches to your note. So I think here it was 0.5 times 45 degree chamfer, or something in that sort of vein. So yeah, the way, let's say I want that chamfer on the next line down, you wouldn't just hit enter there, you would actually squash the text box down slightly so that you have the ability to justify these things on whatever, however many lines is convenient for you. So yeah. So that's essentially it. That's kind of a brief introduction to quite a few different drawing skills. As I say, some of them are specific to assembly drawings, some of them are just generic SolidWorks drawing skills. I think the last one that we'll cover is, obviously you would want to then take a save of this. So we could save that wherever we're going to save it. Chain case, so I already have a copy in there, so I'll probably put a number 2 at the end of it. So yeah, you can see it's auto-updating the actual name of it. So say that sheet format was the format that we wanted to then take forward into all our future drawings. You could go to the File menu and say Save Sheet Format. And then by default it tries to save it into the SolidWorks installation directory. You can do that, or you could send it into a different directory. But basically, if you save that sheet format somewhere, the next time you come to create a drawing, so let's imagine that we were about to create a new drawing, you could browse to the location that you'd saved that format into and just load that format in. And you wouldn't have to do any of that work editing the actual sheet itself, the sheet format itself. So yeah, I think that's about it for this tutorial. As I say, there'll be a parts drawing tutorial as well that covers some specifics to do with parts drawings, but that's a reasonable introduction for the time being.